6-2, exponential models. So for exponential models, we're going to be looking at real world examples. Okay, so first off, you want to somewhere jot down that formula, have a place where you can easily access it or know where to find it, because we will be using it. Compound interest are things like credit cards, things like savings accounts, things where you're going to make money off of the money you already have sitting in that account. Or in the credit card case, the credit card company starts making money off of you because they're charging you interest for originally using their money. Okay. So I'm going to dive right into the example to show you how to use the formula. All right, so we're going to find A. What is the value after the time and that we put it in there? P is the principal, which is how much did we invest in to begin with. So in this case, $3,000 is invested. The 1 is always there, so you're always going to write the 1. The rate is the percent divided by 100. So 3 divided by 100 is actually 0.03. If you're one of those that likes the memory trick, it's move the decimal place 2 points over. Okay? And then N is the hardest one to know. So number of compounding periods per year. So if I think about monthly, I have to think how many months are in a year. There are 12 months in a year. So that is N. So everywhere I see N, there's 2 parts. I'm going to put 12. And then my time is 10. Okay. Then I'm going to use a calculator because I'm not trying to do all of that on my own. I can open up Desmos. 3,000 parenthesis 1 plus 0.03 divided by 12. This part's no problem. So if you kind of zoned out on me, please watch what I do next. When I raise it to the power, since I have to do 2 things together in the power, I'm going to put those in parentheses, the 12 times 10, so that it all stays up in the exponent. Otherwise, you're going to struggle with it staying up in the exponent. Okay. So that is my answer. $4,048 If I round to the nearest cents, it's 0.06. So after 10 years, the 3,000 would still be there, but you would have an additional $1,048.06. What about after 100? Well, the only thing I would do that exact same formula, except I would make it 100. And Desmos makes that super easy for me to just go back in there and put another 0. Ooh, I like the sound of that. I would then have $60,000. $60,031.45. Okay, so you always want to round like it is money. There is a situation where you have continuously compounded interest. If you have continuously compounded interest, we call that PERT. And it's A equals P to the ERT. Okay, so E is just a number. Just like pi is a number, so is E. So it's approximately 2.718. Just like pi is 3.14, E is approximately 2 0.718. You don't have to memorize that because your calculator is super smart and it's going to tell you that you're just going to type E and it's going to know. So if I have A equals, I'm investing $125,000. I wish I had $125,000 to invest. E to the rate, remember I have to divide it by 100 to get 0.0475. T is still time, so my letters haven't changed. I just have to know that E is continuous. And so then go back to Desmos. If you are on a phone, you can hit this ABC and just hit E. Raise that to the parenthesis 0.0475 times 15. So after 15 years, I'm going to have $254,885.32. And then part B says, what about after 30 years? So I would just change T to 30. And I would have $519,732.23. Whew, what a mouthful. What a lot of money. So I'm going to go back to my notes and write those answers down. All right. So compound interest, even though it's a real world problem, they're pretty easy to solve, especially compared to other real world problems, which I know are scary. All right, for our last example, we need at least 2 points, and we're going to use Desmos to create the formula for us so that we don't have to do all the algebra behind it. There is an algebra way to find it where we're like solving for the letters. But Desmos is super smart for us, so we're going to use our programming aspect and our IT knowledge to get it through. So we're looking at a surveyor who determined the value of an area of land over a period of several years since 1950. It was worth $31,000 in 1954 and $35,000 in 1955. Okay, so we want to use the data to determine an exponential model that would describe the value for the land. Okay. So we have 1950 is going to be our x value of 0. We don't know what that y value is, so we actually won't use that point. But that means that 1954 is $35,000. Oh, sorry, 1954 is 4 years later, so the x value is 4, y value is 31,000. And then in 1955, the y value is 5, or sorry, the x value is 5. Whew, words are hard. Y value is 35,000. Those are the 2 points that we need to know. So what we're going to do is go to Desmos. If we've been doing anything else in Desmos, we're going to clear it out. We're going to go to this little plus sign at the top and hit table. And we're going to put 4, 31,000, and 5, 35,000. And then we're going to type in the formula so that it will tell us A and B. Once we type in the formula, we're done. So we're going to type Y1, and it'll automatically kind of do that. Then we're going to hit the tilde symbol, which if you are on your Chromebook, that's going to be in the very top left. Hit shift and then that button. Then we're going to hit A, B, raised to the x1. Okay. And so we'll notice that we have $19,078.20, and then B is 1.129. Well, I'm going to go ahead and tell you that when you buy a house, they typically round it to the 3 zeros. So like, we're going to sell this house for $250,000 because it's 0, 0, 0. So we're actually going to say that A, so if we're going to say the function equals A times B raised to the x, we're going to say A is 19,000. B was 1.129, which rounds up to 13, raised to the x value. So we've answered the question. We have given an exponential model. Why would I ever want to give that model? Because I could then use that model and estimate how much the land would be worth in the year 2000 or in the year 1989. All I would have to do is plug in for x to get that value. So models are nice to give us a value later.